How is it going?
Fine, everything is fine.
You are in Nigeria now?
Yes, from Nigeria.
Yes, mashallah.
Yes, as you can see, I just wear my, traditional, clothes.
That's very nice.
Yes, that's good. Uh, so can
Uh,
we introduce ourselves and go ahead?
Can I start now?
Sen başla, ben konuşurum.
Başlayabilir miyim hocam?
Yeah, brother.
Ha?
Okay.
Merhaba, hoş geldiniz.
Okay. Hello, participants. As I can see, I have about 7 participants or 8 in the group. This is 9th International Student Science Congress that is taking place in İzmir or Manisa, that is in Turkey. This is Hall 2, Session 23. From my list here, I have about 7 participants or presenters in this group. The first presenter will be Abdifatah, Adan, Hassan, and Hülya, İlbi. And the second participant with the topic molecular marker-based identification of tomato spotted wilt virus resistance in paper genotypes from Turkey and Nigeria. That is the first presenter.
Yeah.
And the second presenter will be Shamsuddeen Abubakar, Abdulmajid, Babangida, Umar, and Aminu, Yusuf. And the paper titled Optimized Hyperparameter Tuning for Software Defect Prediction using Gaussian random PVC numbers and Evidential Neutral Network. That is the second presenter. So all of the presenters should be ready. The third one is Deniz, Çira, with paper titled Determination of Fish Health Using Machine Learning and Image Processing Techniques. And the fourth paper will be that of Alkhansa O M Abdalla, which is load flow analysis with Higlig Basin grid as study case. And the sixth paper is that of Tilina Tuabi, okay? An enhanced particle swarm optimization technique for photovoltaic panel parameters identification. And the last one is to be presented in Turkish language, which is, if I can read it, even though I spent some few months in Turkey, which is Ege Deniz'in de deniz yüzey suyu sıcaklığının ödü verileri ile analizi, okay? Which is from Aziz Ufajik and Nevim Batul Afsha, okay? So now without wasting much of our time, maybe I will call on first presenter, which is Abdifatah Adan Hassan, to present his paper. As you all know, the paper presentation is just 15 minutes, okay? Including questions and answers. So now we are calling Mr. Abdifatah Adan Hassan to present his paper. So you can share your slides and continue, please. Abdifatah Adan, can you hear me, please?
Yeah. I can hear you. Yeah. Do you hear me now? Do you hear me?
Yes, you can go ahead, please.
Yeah. Do you see my article?
Yes, you can share your slides, please, so that we proceed, please.
You see now?
No, I can't see it.
You can't see it.
Just maybe as a result of network burst, follow it carefully, please.
Now what about, you see now? You see? It's good. Yeah, I can hear your voice, but if it is good, you can do like this. You see? Yeah. Let me start. And I'm first of all, and my name is Abdifatah, and this is my topic. And
I said, can you hear me?
yeah, I can hear you, of course. What about
Okay, so you
Good.
can go ahead.
Yeah, thank you. Türkiye ve Nijerya kökenli biber genotiplerinde domates lekeli solgunluk virüsüne karşı direncin moleküler belirteç temelli tanımlanması. Yani benim konum bu. Giriş yapacak olursam, bu çalışmadaki amacım Türkiye ve Nijerya'da yetiştirilen biber genotiplerinde, dur bu videoyu bu tarafa alayım.
Go ahead.
Ya.
Divan.
Devam ya. Bu çalışmadaki amacı Türkiye ve Nijerya'da yetiştirilen biber genotiplerini domates lekeli solgunluk virüsüne karşı dirençli veya hassas olarak sınıflandırmak ve her iki ülkenin biber ıslah programlarına dirençli genotiplerin entegrasyonu yoluyla birim kayblarını azaltmaktır. Biberin kökenli ve yayılışı başlayacak olursak, Solanus familyasına ait olup Amerika kökenli bir bitki olup 1400'lerde Columbus ile Avrupa'ya, ardından Afrika'ya ve Asya'ya yayılmıştır. Osmanlı'da 1600 yılında İstanbul üzerinden Anadolu'ya dalmıştır. 43 tür tanımlanmıştır. Önemli türler arasında Capsicum annuum en çok yaygın ve en ekonomik türü, yani kullanılan arasındadır. Capsicum annuum. Başka ne var? Capsicum fraxens, Capsicum Chinese, Capsicum bacatum ve Capsicum basicens. Türkiye ve Nijerya'da biber üretimi bakacak olursak, Türkiye dünyada 3. sırada olup çeşitli türler geniş üretim, kırmızı biber 1,6 milyon ton, dolmalık biberler 395 bin ton olmak üzere dünyadaki biber üretim katkısı sağlamaktadır. Ve Nijerya'ya bakacak olursak, Afrika'daki toplam üretimin %50'sini karşılıyor. En büyük tropikal üreticisi olup ve biberlerde 2001 verilere göre 1,49 milyon ton üretmiştir. Hastalığa bakacak olursak, domates lekeli solgunluk virüsü TSV olarak bilinen bu isim Tospophyllus cinsi olup 1915'te Avustralya'da tanımlandı. Etkilendiği bitkiler familyasında 90 üzerinden, yani 1090'dan fazla tür etkilemektedir. Yayılışı ve zararlarına bakacak olursak, onu yayan vektör batı çiçek trips olup etkilenen başlıca bitkiler biber, domates, marul, patates. Belirtiler arasında, yani onu hastalığı belirtileri, bitki üzerindeki belirtiler bozurluk, solgunluk, halka lekeler, nekrozlar, verim kaybı. Bu hastalıkla mücadele için kimyasal mücadele çok zor. Ve en önemli ve yani çalışma için, yani bunun iyi verim almak için dirençli geni kullanmaktır. TSV karşı dayanıklı Capsicum Chinese türünde TSV geni olarak bilinen biberde TSV karşı hibrisentif direnç sağlar. Biber yetiştirildiğinde TSV karşı şu anda yalnızca TSV direnci geni mevcuttur. Tek gen mevcuttur. O da Capsicum Chinese türünde mevcuttur. TSV genini taşıyan biber çeşitlerinin küresel ölçekte yaygın kullanımı direnci kıran TSV suçlarının hızla evrimleşmesine veya yayılmasına neden olmuştur. Materyale bakacak olursak, bizim kullandığımız Capsicum'lar 21 tane genotip Ege tarımsaldan Ari, yani Türkiye'de elde edilmiş 21 genotip, 39 örnekte Nijerya'dan Ulusal Genetik Bankası'ndan temin edilmiştir. Toplam 60 genotip analiz edilmiştir. Ve bu genotipler şu şekilde: soldaki 1'den 21'e kadar yerli olup 17 tanesi zaten gördüğünüz gibi capsicum annuum. Geri kalanı 4 tanesi de capsicum fructus olmak üzere 21 tane yerli biberlerden. Kalan sağdan 22'den başlayan ta 60'a kadar da Nijerya'dan temin edilmiştir bu biberler. Bu çalışmada ayrıca kullandığımız kontrol amaçlı genotipler vardır. O da 3 tane. PI 15 225 Capsicum Chinese'ten kaynak Amerika genotipi dirençli homozigottur. İkincisi de genotip Demre Capsicum annuum kaynağı da Antalya Türkiye'dir. Genotipi de dirençli heterozigot. Üçüncü de HV12 kaynak Fransa genotipi de duyarlı homozigot küçük reller yani. Metotlara bakacak olursak bu 60 genotipi artı kontrol için kullandığımız bu 3 genotipi toplamı DNA izolasyonu yaptık. O da Doyle and Doyle 1991 TITAP yöntemiyle izolasyon edilmiştir. Ve DNA izolasyonu takiben PCR uygulaması yapılmıştır. PCR reaksiyon karışımı da şu aşağıda gördüğünüz bu şekilde. Yani tamponu, DNTP, magnezyum, primerler, tag primer yani solda gördüğünüz PCR reaksiyon karışımı uygulanmıştır. PCR döngüsüne protokolüne gelecek olursak denaturation yani denatrasyonu olarak bağlama, uzama şu sağda gördüğünüz şekilde uygulanmıştır. Ve son uzama olarak. PCR ile hedef bölgeleri çoğaltıldı. Amplifikasyon ürünlerini yani çoğalttığımız PCR'da çoğalttığımız genotipleri %1.5 agrosgel ile ayrıştık yani görüntüledik. Göstermede itidium bromür kullanılıp UV altında görüntülendi. Ve bu işlemden sonra restriction enzimi kullanıldı kesim için. Bu çoğalan genotipleri reaksiyon yani restriction enzimi kullanılarak takbir kullanılarak kesim uygulanmıştır. Tüm genotipleri PCR ürünlerine çoğaltılmış oranı takbir enzimi ile kesim işlemi yapılmıştır. Kesim işlemi de kullanılan PCR ürünü miktarı, enzim miktarı, tampon, steril su, inkübasyon sıcaklığı ve inkübasyon süresi olarak bu sağda gördüğünüz verilere uygulanmıştır. Şimdi bulgulara gelecek olursak PCR amplifikasyonu ve gel elektroforezi yani elektroforez sonuçları 60 biber genotiplerin izolasyonunu takiben DNA örnekleri SCAC 568 primeri ile PCR amplifikasyon edilmiştir. Yani çoğaltılmıştır. Kesim işlemi için takbir enzimi kullanılmıştır. Şu gördüğünüz gel de takbir enzimi ile kesilmeden önceki yani çoğaltılmış genotipleri görüntülüyorsunuz. Bu gördüğünüz aşağıdan yani marka olarak da yüzlülük pasper kullandık. Aşağıdan başlayarak 100, 200, 300, 400, 500 şu gördüğünüz işareti ki 500
Abdifatah,
efendim.
5 dakikanız kaldı.
Tamamdır. Şu
Devam,
ikinci de
devam.
Şu ikinci gördüğünüz de kesilmiş hali, takbir ile kesilmiş hali. Eğer iki tane bu başta küçük r'leri görüyorsanız bu hassas demektir. İkinci de büyük R ve küçük R o da heterozigot. Yani 3 bant gözüküyorsa o da heterozigot dayanıklıdır. Tek bant 568'de gözüküyorsa o da büyük R'ler dayanıklıdır. Bizim yani genotipimiz. Bu 3 farklı genotip yani kontrol amacıyla kullanılmıştır. Bunları da onlar da takbirle kesilmiştir. Onlar da aynı sonuç vermiştir. Yani Demre'ye bakacaktır. 3 tane yani bant heterozigot demektir. PI tek bandı 568'de bantı o da yani homozigot dayanıklıdır. HV12'de şu aşağıdaki iki bantta heterozigot yani homozigot duyarlıdır. Yaptığımız çalışmaların hepsi toplamı şu şekildedir. 60 genotipin elde edilen bu mavi açık mavi gösteriniz büyük R küçük R olup büyük maviler yani renkli mavilerde yani net olan mavilerde homozigot dayanıklı olmaktadır. Nijerya kökenli biberleri daha yüksek çıkmış, tespit edilmiş. Yani onların nedeni de genetik çeşitlilik, evrimsel baskılar, Diğer nedeni de geleneksel tarım ve seleksiyon yöntemleri de bu özellikler yani söz konusu genotiplerin gelecekteki ıslah programının aday ebeveyn olarak değerlendirim potansiyelini arttırmaktadır. Sonuca bakacak olursak bu çalışmada takbir ile kesilmiş genotiplerimiz 13 genotip homozigot dayanıklı büyük R çıkmış. 24 tane heterozigot dayanıklı büyük R küçük R çıkmış. 23 tane de hassas çıkmıştır. Biber ıslah programının TSV karşı dayanıklı duyarlı genotiplerin belirlenmesinde İSKAK 568'de bu şekilde kullanabileceğini göstermiştir bizim çalışmamızda. Ve biber ıslah dayanıklılığının hızlı bir şekilde tespit edilmesine olanak tanırken dayanıklı ve duyarlı genotiplerin seçimi kolaylaştırmıştır. Islah programları da bu ebeveynleri kullanılarak hem Nijerya hem Türkiye'deki gelecekteki biber üretimi daha fazla arttırmak ve çevre içinde büyük bir önem taşımaktadır. Bir de diğer önemi de genetik kaynakların korunması. Bunu kullanarak yani bizim elde ettiğimiz dayanıkları her iki ülkeyi kullanarak gelecekteki genetik kaynakların kullanılabilir. Yani oradan edilen hetero genotipleri kullanıma sokulabilir. Yani domates lekeli solgunluk virüsüne karşı dayanıklılık göstermesi her iki ülkede biber tarımında yaşanan tüm kayıpları azaltmasıdır. Tarımsal ürünlerin verimliliği arttıracak önemli katkıları sunacaktır. Dayanıklı çeşitlerin tarımsal üretiminde pestisit gibi kimyasal giderlerin kullanımı minimize edecek, daha çevre dostu, sürdürülebilir tarım sistemini geçiş destekleyecektir. Son olarak da bu yaklaşımlar yerli ıslah programlarının daha modern, yenilikçi ve rekabetçi bir yapıya kavuşmasına katkı sağlayarak biber üretiminde sürdürülebilir ve verimli çeşitlerine giderilmesini hızlandıracaktır. Teşekkür ederim.
Teşekkür ederim. Güzel sunum bir katılımınız için teşekkür ederim.
Çok teşekkürler dinlediğiniz için.
I think we are going to call the next presenter, which is the next presenter, please. Who is Shamsuddeen Abubakar.
Yes.
Optimized hyperparameter tuning for software defect prediction using Gaussian random Poisson numbers. And
Good.
evidential neutral network. So you can go ahead. You have exactly 15 minutes, including questions and answers. You may
Okay.
wish to go ahead, please.
Okay, good afternoon, everyone. As it was said, my name is Shamsuddeen Muhammad Abubakar, and I'm presenting a research titled An Optimized Hyperparameter Tuning for Software Defect Prediction using Gaussian random Poisson numbers with evidential neural networks. To start with, we are introducing this novel approach to improve software defect prediction by integrating Gaussian random Poisson numbers with evidential neural network. We aimed at automatically and dynamically removing correlated metrics that degrades the model computational efficiency, accuracy, and which enhances the prediction performance. The research will, however, cover the problem of correlated metrics, the proposed hyperparameter tuning method, and how are the steps to implement the proposed approach. And at the end, we are going to see the resulting improvement that will be made in the software defect prediction models. Now, part of the challenges that literature has been elaborating on software defect prediction are majorly three. The recent trend in software development industries have highlighted three major factors that are influencing the accuracy or processing efficiency of the proposed models. Basically, there are three. The first one is the impact on the models. Correlated metrics add irrelevant informations, and feature redundancy. This, however, increases processing time, thereby reducing the model accuracy and increasing the overfitting risk of the models. When the parameter settings are default, this has been highlighted by previous researchers, which they said prior researchers used default hyperparameter in tools like R, Weka, and scikit-learn, which led to suboptimal defect prediction performances. And lastly, the computational cost was as a result of high dimensional data, which many parameters require more training data and computational resources. This will be complicating the model training and model interpretation, as said by these researchers. So our aim is to improve on all these shortcomings made by prior researchers. Now, to go further, we need to highlight on the importance of hyperparameter optimization. Part of it, we are defining hyperparameter as finding the best or an optimal settings that are used in making the prediction. Parameters like learning rate, number of neurons, and complexity control, all of them are having some issues. Prior researchers used to make them manually, which we want to optimize it. Part of its effect on software defect prediction model is an inappropriate hyperparameter settings, which degrade the prediction accuracy and make the model to be instable, which results in computational complexity of the models. Now, we need to make an adjustment by making an automated and dynamic hyperparameter approach that will solve.
Okay, go ahead, please.
Now, the next thing that we are going to see is the steps that we followed in achieving the said objective. The first one is we are employing the Gaussian random fuzzy equation, which we leave it as it is. The second stage is we are devising another technique, which is the introduction of correlation-based adjustment factor, which we created, and we wanted to try and modify the first step. The third step is we are going to employ this first step and the second step so that we merge them into a new and a modified technique. The 4 to 6 steps are the model training and integration of the proposed hyperparameter into the evidential neural network. Now, here is going to be the mathematical approach or the formulation of the model. As we said, the first stage is we are defining the initial Gaussian random fuzzy number, which the first part of the equation represents the Gaussian membership function. They represent the matrix values in the feature in the data set. M is the mean of the correlated matrix, where H represents the hyperparameter that control the width of Gaussian function, which adjusts the sensitivity to input variables. At this stage, we assume that the model operates with a static H, meaning that it does not account for any correlation at this stage. The next stage is we are introducing the correlation-based adjustment factor, which our improvement starts from here. We wanted to address the issue of feature redundancy and correlation. Thereby, we introduced a scaling factor, which is alpha equals to 1 to the summation of the correlation coefficient between the features I and the features J, where omega is the factor that amplifies or reduces the effect of correlation. Why we started by using 1 there is we wanted to use Pearson correlation coefficient to degrade the effect of the correlation in the matrix. If the omega is 1, it means that the penalty is directly applied on the features. However, if the omega is less than 1, therefore the penalty is softer.
Okay,
As
so
well
you
as
have-
if I
you
will
have
be
less than 5 minutes or 5 minutes to round off, please.
okay, sir. At this stage, we ensure that all the highly correlated features receive higher value of H, thereby reducing their influences. The third stage is we are computing the modified H correlation, which is the modified hyperparameter of our equation. And at this stage, we ensure that features that have higher correlation will have an induced penalty factor, which make it redundant feature. The fourth stage is we are substituting the values of stage 3 into the prior stage 3, stage 2. Therefore, we are having the first equation there. The next stage is we are expanding for the entire equation, which we come up with the fifth equation. At this, the equation ensures that features with high correlations are down-weighted, which reduces the redundancy, and this will increase or improve the model robustness. The fifth stage is we are optimizing the hyperparameter, which the final loss function was incorporated with multiple hyperparameters, such as the linear rate and number of layers that will result in the sixth equation. This stage ensures that hyperparameter tuning account for features correlated, which improves defect prediction performance of the model. The last stage is we are integrating the modified fuzzy function into a training, which we embed it into the evidential neural network, and that will optimize the hyperparameter tuning of the general model. The results is anticipated to improve the prediction performance of defect prediction models, which will optimize the hyperparameter tuning, thereby increasing the efficiency, precision, recall, area under curve of the entire model, as well as reducing the overfitting of the model which correlation-based penalty factor decreases the influence of redundant features and mitigating the overfitting. Finally, it will increase the stability of the model, which a dynamic hyperparameter adjustment will lead to a more adaptive and stable model training. Sorry. In terms of computational efficiency and scalability, the automatic adoption of the model will adjust to data sets without manual correlation thresholds or extensive pre-processing approaches. The resource optimization will also reduce the computational overhead, which was compared to prior traditional feature selection methods. Lastly, the scalability, which enhances the high-dimensional software defect data. The model will enable broader application across industries. In conclusion, our key contribution in the research is the introduction of a novel hyperparameter tuning, which integrates Gaussian random fuzzy numbers and evidential neural network. Secondly, we are automatically removing correlated metrics in our model. Lastly, we are providing a technique that will improve the processing time, prediction accuracy, and reduces the false positive. The impact of this research is it will enhance software defect prediction robustness, efficiency, and generalizability across data sets. That will bridge the theory and practice for software defect prediction between practitioners and industries. The future research direction will look into an automated hyperparameter tuning. We want to develop a fully automated process to software defect prediction, which optimizes parameter without manual intervention. Real-time defect prediction that will extend approaches of live monitoring and prediction during software defect prediction cycles. Model interpretability. Our model will improve the understanding of model decisions to aid development in defect predictions. This research will advance software engineering by creating efficient, scalable, accurate defect prediction models, which promises future enhancement. Thank you for listening.
Thank you, Mr. Presenter. I think you have a very good presentation. So I don't know if there is any question from participants. So in the absence of any question, my question is just maybe one. So do you use Gaussian software for this optimization or what?
No, it's not a software. The software is evidential neural network. While the Gaussian random fuzzy number is an equation.
Okay, equation.
That is, yes, it's an equation.
The reason why I
modified
you, there is one software. It's for optimization of some chemical, molecular, I can say maybe density functional theory like this, that is predicting movement of, electrons from maybe acceptor to something like that. There is software that is called Gaussian software, which chemical students are using.
Oh, that's right.
Okay.
Yes.
So I think this is a very good presentation. In the absence of any question, I think you can go ahead and call on the next presenter. So thank you for the presentation.
Thank you, sir.
Welcome.
Welcome.
So the next presenter is Deniz Çira, and the paper title is Determination of Fish Health Using Machine Learning and Image Processing Techniques. So, Deniz, may wish
Hello.
to go ahead, please.
Thank you so much.
Mm.
Clear? My screen is clear?
Yes, I can see it. You can proceed
Okay, thanks
with
so
your
much.
presentation. Yes.
Dear, so sorry about that. Dear participants and dear academicians and also the students, welcome to my presentation. Today, I'm gonna tell about the determination of fish health using machine learning and image processing techniques. The purpose of this presentation is to introduce you to these emerging and increasing populatory diagnostic technologies in aquaculture, and maybe you can find a new collaboration and partnerships about this field. You know, the fish products constitute an important part of the human diets because they are an excellent source of nutrition such as proteins, vitamins, minerals, omega-3 and EPA and DHA acids. And also the regular consumption of this fish and seafood products, many benefits for the human body. For example, the improved cardiovascular health, enhanced cognitive functions, and reduced inflammations. The fish disease is an important way for this suspect because the diseases not only adversely affect the quality of life of the fish, but also lead to significant economic losses in the aquaculture sector. In particular, in aquaculture facilities and high stock densities, disease can spread rapidly, resulting in mass mortalities, growth retardations, and decreased feed conversations efficiently, and this is cause of the reduced product quality. All these conditions, controlling the fish diseases and developing early diagnostic methods are the critical important role for ensuring the economic efficiency and sustainability of the aquaculture sector. We use the traditional detection methods in the veterinary medicine field and aquaculture specialist methods and aquaculture and engineering. We use systematic veterinary examination, appropriate anamnesis, evaluation the environment conditions because the fishes are the cold-blooded animals and the water is the main factor of the fish immune system quality and healthy. And after we inspect the fish, the external surface to lesions or other ulcerations maybe, and physical examination. After unfortunately, the many fish that because of the fish diseases and the high stock qualities before I said, and we use the necropsy methods and we determine and identify the parasites, maybe bacteria, virus, and fungus. And also laboratory analysis, we use the other macroscopic and microscopic examinations and molecular technique we use, for example, PCR or the RT-PCR. And after I said before, the water parameters, the importance, for example, the salinity and hardnesses or the temperature is directly affect the fish health and immune system and maybe stimulate or going to the bad way to fish health, maybe. And but the limitations in the traditional methods for this diagnosis, for example, the subjectivity result depends on the observed experience. For example, I saw the white spot disease parasite in the Ichthyophilus multifilus. I saw before, and I will see the new one, and I recognize it, and I identified it easily, but some people don't know the Ichthyophilus multifilus, and it's the differentiation. Low sensitivity in early stages because many diseases are only detectable when symptoms become obvious at advanced stages. Time is important because laboratory tests also the culture in the bacteria or fungus. They have a 21 day for the growth to plate for the identification, and it's really time consuming. Costly and labor intensive, you know, the all materials really cost, for example, the PCR materials also. And this methods, we diagnose the fish diseases early with collaboration with AI techniques in aquaculture. It's the popular way, machine learning and machine systems, deep learning systems, image processing techniques, classification, for example, all the other fish species classification with the machine learning techniques, and disease detection and diagnosis is our topic. Take a look to machine vision. Many machine vision techniques in front of you. Artificial neural networks. This system inspired by the human neurons made up the artificial neurons like single layer perceptron, simplest neural network. It can only separate two groups, the other. And the others, and the YOLO, you only look once, is the new and deep learning algorithm, and it's the effective way for now. These tools for invasive underwater monitoring of aquatic organisms at the farm that can eliminate air exposure and handling, reducing stress, improving growth, and support the welfare or the fish. Image processing techniques has been used in aquaculture in various applications, such as determination fish diseases, weight, land measurements, classification, counting, on detection, tracking, identification. You see the cameras inside of the outside of the pools, and we take pictures of the fishes in the natural way, and we take them to the computer, and we processing it, the all photos, and after we use them the other projects or other usages way. And the process begin with the acquisition of fish images. We put the many fishes photographs, many disease, sick fishes, parasites, bacteria, or something like that in all microscope cameras, imaging devices. And the next step is imaging pre-processing, and to test this technique enhance image quality such as denoising, sharpening, smoothing, and Ismail like a Photoshop like. And after pre-processing, the systems perform image segmentation and isolate the lesions and abnormal areas for the fish. After feature extraction follows the characteristics such as the color, texture, or shape, and identify the all symptoms, the whole fish, and the specific disease. And this technique, I said, the acquired image in this first title, and resize the image we accurate for the preparation, and contrast straight images and segmented images. This is our diagnosis for this fish diseases. And after many techniques, you know, and they are improving for now, very useful for the aquaculture industry. This article used the faster CNN techniques, and the model has a 5,200 labeled fish images. This is the huge fish population, but the deep learning wants more. Exactly. Symptoms observed in the images and were analyzed automatically by the system, and this achieved performance mean average presence is 87 persons. It's a good persons, and this way. This CVM, support vector machine systems they use, and this system is healthy fish and diseased fish separate each other, and they learn it, teach. We are teach the machine learning, and they are learning to other fish populations healthcare status determination. And this is the last research, the new research. Fish parasites were automatically detected. This is the many fish disease factor in the same side. And this is very dangerous way because the mortality is very speed for this situation. And automatically detecting using the YOLO, I said before, this is the new way and really good separate the all symptoms each other. A large data set was used, for example, the 2700 and overall accuracy is you see the 95. It's really achievement, and this is the fast and accurate detection was possible in both single and multiple infection. You see this is the three parasite in here, Ichthyophilus multifilus and this, and this is the Argillus, and this is the Dactylogyrus, and this are separate each other for the system, with the system. We come to conclusion and discussion. Imagine processes and computer vision provide non-destructive, yes, rapid and real-time diagnosis for the fish diseases. Camera and spectral images enable live fish disease detection without harming fish bodies and protect the fish welfare in this point. Image enhancement in aquaculture must be tailored due to light scattering and water turbidity. And many systems include all type. And future recommendations. Image processing and computer vision are becoming indispensable for the rapid and reliable diagnosis of the fish disease in aquaculture. The diversity of fish species, the complexity of aquaculture environments, and technical limitations in image quality presents ongoing challenge for effective implementations. And also the veterinarians and other aquaculture specialists play a crucial role in this interpretation and proper application of this new technology. And future research should focus on developing more robust accessibility and special exclusive diagnostic solutions, and on training specialists to interpret automated results reliably. Thank you for listening to me.
That is a very good presentation. So is there any question from the participant, please? So maybe I have just one question, please. And my question is that how efficient these methods, as we know that AI, maybe it is going to, it is emerging technology, isn't it? So how efficient do you think this method is? Okay, the efficiency of these methods compare with the conventional methods that we use, chemicals in the laboratory and test the diseases present. So how efficient do you think this method is?
Actually, for example, the one features in the fishes or other animals, because I'm a veterinary medicine doctor, and we come to them and after a microscopic examination, and I want to find an egg, a parasite egg, for example. And
Yes.
sometimes I prepare enough preparates, and maybe I didn't find, but it's in here. And these techniques in fish medicine or other fish disease determination, the AI technology will see and how can I say, emerge me to take a look.
Exactly.
And this is the effective way for the veterinarians, also medicine, normally human medicine is really efficient, I think.
Okay, that's good. So I think in the future, so please just try and know the actual efficiency of this compared to the traditional method or conventional methods, because maybe we know that in the future we are going to maybe stop using laboratory techniques, isn't it? Even though AI now is emerging technology. Because we know that most of the techniques that we are using in the laboratory, we are using some harmful chemicals. So in the future, we don't want a kind of use of these chemicals, isn't it? So just try and add value to this presentation. Okay.
Yes.
So I think you have a very good presentation based on this, and I really learned a lot from your presentation. Thank you very
so
much.
much. Thank you so much.
Yeah. Bye-bye. So I think the next presenter is Alkhansa. As I can see the slides here, Alkhansa O M Abdalla, and the title is Load Flow Analysis with Higlig Basin Grid as Case Study. So I think, as you all know, that I'm from Nigeria. I'm joining you from Nigeria, and now it's almost time for the Friday prayers. So I think after this presentation, we are going to wait for about 20 minutes. I'm going to observe my Juma prayer. So immediately after the prayer, I will come back, maybe after 20 minutes, immediately after this one. Okay, so all the participants are expected to come back, please, because at the end of the presentation, there is going to be a kind of group picture, please. So Alkhansa O M Abdalla, you may wish to proceed for your presentation, please. Alkhansa. I can't hear you, please. I think you have to on your mic, please.
Can you hear me?
Yes, you can go ahead. I can hear you now. You have 15 minutes for the presentation, including question and answers.
Merhaba. Welcome everyone. Today I will be presenting a study on load flow analysis using the Higlig Basin grid as a study case. This presentation highlights the challenge solutions and tools applied in managing load distribution in a growing energy network. Load flow analysis is a determination of current, volt, active power, and reactive power, reactive volt amperes at various points in a power system operating under normal steady state or static conditions. Load flow studies are mode to plan the best operation of the existing system, as well as to plan the future expansion to keep pace with the load growth. The mathematical formulation of the load problems results in a set of algebraic nonlinear equations. A lot of calculation work involved in the solution of these equations. The problem, electrical network expansion brings complexity, load distribution imbalances due to unplanned growth, lack of accurate data on physical network parameters, specific focus, Higlig oil fields. The study case area, Higlig oil field. Uncontrolled expansion of power networks often leads to poor load distribution. This was the case with the NEC grid supplying the Higlig oil field, where expansion efforts faced technical obstacles due to outdated or missing data. Here, the Deniz NEC, we mean Sudanese National Electric Company. Objectives. The main objective of this study is to investigate the analysis steady state condition for GNBOC, Greater Nile Petrol Oil Company network using the NEC load flow analysis backing. The study includes the modes for power system elements in addition to load flow equation. The second objective of this study is to simulate the effect to adding or rejecting a new load generating and line the existing GMBOC network. Techie, what the load flow analysis? The program essentially consists of 3 modes. The main routine network modification subroutine for performing system outage and network solution subroutine in the sense that any nodal analytic method can be used for the latter, whether the Gaussian Newtons or decoupled algorithms. The program includes facilities to show bus voltage, megavar flow, current flow, megawatt flow requirements of system, which is useful in planning for compensation when the existing variable and static compensation are unable maintain responsible volt profile. The problems has visual editor and is very to use by any electrical engineer. The program has visual editor and is very to use by any electrical engineer just by selecting the desired icon for any element of the power system and building up the network from the scratch. The program offers the ability of adding, deleting, or disconnecting any element of system. Each element can be handled separately for input, changing or deleting its data. The result of the load flow program can be taken as reports or printed on the network. Problem network, Higlig Basin from the main source for Sudan oil fields GMBOC network began with a small network, then grew quickly by adding more oil fields of transmission lines to transmission lines, so that is becomes large and complex, so that many problems began to areas such as instability of the voltage, line overloaded, frequently blackouts, and so circuit breakers. Description and data, network description and data. GMBOC fields consist of 2 main oil fields. Higlig falls on 29/8, 10 north, and Unity is about 70 kilometers southeast of Higlig. The whole area falls in the Acacia Sales Tall Grass savanna zone of the Sudan. The system description, the system consists of 64 bus bars, 13 generators, 3 2-winding transformer, 4 3-winding transformer, and different types and sizes of transmission lines. Here, methodology is the point of methodology, application of computer-based simulation tool, load flow modeled on NEC's grid, simple interface overall from standard DCs, scenario testing for future expansion. A user friendly simulation tool was created that allowed engineers.
Try and round off. It is almost remain 4 minutes. Yes.
Sorry?
Try and summarize. Okay. Remain 5 minutes for your presentation. I said try and summarize. Okay.
Okay, okay.
Mm.
Some of that is a final. Here from above tables, observe that light mode is optimum. We have a 3 mode, light mode, pardon. We have a 3 modes, peak load, medium load, and light load. From these tables, we can observe that the light mode is the optimum option, the medium and peak modes. The recommendation using capacitor banks, installed generator units in remote load locations to increase reactive power, using the double circuit for the single circuit long transmission lines, and so using double lines instead with the single line diagrams. Thank you very much.
Thank you very much for your presentation. Any questions from the participant, please? So I think in the absence of any question, let me just ask you one question, please. Do you think in the transmission line in this Higlig, Higlig Basin grids, are they not using capacitors at all? Do you check that?
Sorry?
I said from your recommendation, you say that supercapacitors should be used in order to, make the transmission to be smooth, to be very good transmission, isn't it?
Yeah.
I said, do you think right now, are they not using these capacitors in the transmission line?
For sure, used that.
Okay, they are using it.
Yeah.
So, but you are suggesting that they should use higher capacitors, isn't it?
Yes.
They should use higher ones. Okay.
Okay.
Are you from Sudan? Higlig is from Sudan, isn't it?
Yes, I'm from Sudan.
Okay, that's very good.
And so this study is old study. Sudan were before the Sudan were 5
yes,
years
not
ago.
flow. Yes.
Yeah.
And this Higlig Basin is around the oil fields there in the Sudan.
Yes.
So that is, I think this is a very good presentation. So congratulations for the presentation.
Thank you.
So just like I said, before we go to the presentation of Selina Tuabi, I think just like I told you, I joined this program from Nigeria. And right now it is time for Friday prayer. Okay?
Okay.
Now is exactly 1:17. I know in Turkey now is 3:17, isn't it? We have difference of 2 hours.
Okay.
So please let us exercise patience. I'm coming back in less than maybe 20 minutes, or let's say 20 minutes.
Okay.
So we are going to finish the remaining 3 presentations, and then we will take the group picture, just like what the presenters, like the organizers, told us. At the end of the presentation, all of us, we are going to on our cameras and, take the pictures of the, for 2 session 23, okay? All of us, after I come back from the prayer, then we are going to on our cameras so that we can take group pictures, please. So please be patient. I'm coming back in 15 to 20 minutes. It is time for Friday prayer here in Nigeria. Thank you very much.
Thank you very much. Allah kabul etsin. ربنا يتقبل.
آمين إن شاء الله. آمين. Because أنا أسمع اللغة العربية قليلا. قليلا إن شاء الله. Yes,
أنا
yes.
لغتي الإنجليزية ليست جيدة لأنني
لا
أتحدث العربية والتركية.
نعم إنجليزية والعربية وتركيش because
Yes.
I spent about 9 months there in Turkey in Ege University during
Yeah.
my PhD. Yes.
Congratulations.
Yeah, in Nigeria we are studying Arabic language very well. Yeah.
Yes,
in
yes.
our secondary school and all places. So
Yeah.
that is why I learned Arabic very well. Yes. So we are coming back in the next 15 minutes. We finish the remaining 3 presentations and then we'll take group picture, please. So all of us, please, should come back in the
I
next.
can't, sorry, I can't promise you. I will have another things to do that.
Yeah, I don't know, but it is their instruction from the organizers. They say that all of us should, be present at the end of the
Okay,
presentations. so that-
20
yes.
minutes? 20 minutes?
Yes, like 20
Okay.
minutes, like that.
Okay.
Yes, yes.
Okay, I
So
will
please,
wait.
because it is prayer, I cannot continue, please.
Tamam, I will
So I
wait
have
in
to
you.
go and yes, I will go and observe the prayer now, please.
Okay,
So please
I will wait
be
in you.
patient, please.
Okay.
There is no any, then I will not go. Okay.
Okay,
Yes. So it is Friday.
by Turkish ممنونية له.
Yeah. It is a cool visit.
Nice to meet you.
Okay, well done. I'm coming back in the next 15 to 20
Inshallah.
minutes. Okay,
Okay.
thank you. Yeah.
Inshallah.
Good afternoon. Are you able to hear me? Good afternoon.
Hi, Selina.
Hi, good afternoon.
Dr. Ismail. Ismail is gone. You can
Yes,
start.
thank you. So, do you see the presentation well?
Yes, we see.
Yes, okay, good. So, good afternoon, ladies and gentlemen. I'm Tuwabi Selina, a PhD student at the Institute of Electrical Engineering and Electronics, University Mohammed Bouguer Boumerdes, Algeria. So, today I'm going to present for you an enhanced particle swarm optimization technique used for photovoltaic panel parameter identification. As it is known, electricity expansion in the 21st century has led to a fast technological, economic, and social development, from which an extreme dependency on it was born. However, the conventional systems used for its generation are no more sufficient, and they are environmentally destructive. Thus, renewable energy technologies powered by renewable energy sources like the wind or solar energy have arisen. One of the most promising renewable energy source is the solar energy, due to its global distribution and availability. The photovoltaic power generation is considered as the main application of solar energy. According to the International Energy Agency, solar PV generation has increased to reach over 1,600 terawatt hours in 2023. The PV cell is the basic element in a PV generator. It can be combined to form PV modules, PV panels, or even strings and arrays to satisfy the required energy demand. The generator is characterized by its current voltage curve as seen in red, and its power voltage curve as it is shown in blue, and it is also characterized by the main 3 points in these curves that are the maximum power point, and the short circuit point, and the open circuit point. Another characteristics is are the field factor, that is the ratio of the actual maximum power into the theoretical maximum power, and the efficiency, that is the ratio of the output maximum power from the panel to the input power from the sun. However, these characteristics vary due to several factors. They vary due to the variation in environmental conditions, mainly the irradiance and temperature. They vary also due to PV degradation with time. These characteristics under the varying environmental conditions or the real operating conditions are not provided by the manufacturers in the datasheet. This is why we need to model them as an electrical circuit. The PVG needs to be modeled as an electrical circuit that has several parameters, but these parameters are not also provided by the manufacturer. One of the well-known models and widely used models is the one-diode model. As seen, this is its electrical circuit. This is the equation describing this model. As you can see, we have several parameters. The VT is the thermal voltage of the PV generator. This PV equation or current voltage equation, it is complex and highly nonlinear, and it has many variables. So to solve this equation, we need to extract many parameters that are the PV model parameters. For the case of the one-diode model, we have 5 parameters that are the photocurrent, the diode saturation current, the diode ideality factor, and the series and shunt resistances. Solving the previous equation, that is the model equation, cannot be done by traditional or conventional techniques. Thus, we need IE or artificial intelligence techniques. In this case, we are going to use meta-heuristic techniques. The particle swarm optimization technique is one of these meta-heuristic well-known and widely used techniques. The particle swarm optimization is inspired from natural phenomena, that is the movement of birds and schooling fish. In the figure, as you can see, we have particle that moves in several directions to reach a certain global best, that is XE in this case. The equation below describes the movement of a particle in this algorithm, such that we have the first equation, that is the equation of velocity. We have several parameters in this equation. We have velocity, and V, and we have omega, that is a damping ratio. We have factors like C1 and C2. C1 represents the cognitive or personal learning factor, and C2, it is the social learning factor. XP is the position of the particle as the current iteration, and we have G is the global best. The second equation uses the calculated velocity to find the next position for the particle, yani the updated position for the particle. So this previous algorithm, that is the PSO, suffers from several limitations. It has like it falls in the local optima. Thus, we proposed better initialization by integrating opposition-based initialization. So opposition-based initialization will modify in the first stage in this algorithm, so that for each particle A, we will create an opposite particle P opposite, described by the following equation, such that A and B are the maximum and the minimum values that this particle can take. Well, in the flowchart, as you can see, A describes the normal initialization process for the PSO, and the flowchart, second flowchart, describes integrating the opposition-based learning. So by this, we will create 2 swarms populations, that is the normal swarm and an opposition-based swarm. And then only the fittest particle from these 2 swarms will be used as the population for this algorithm. This is the main procedure or the algorithm description. And this is the final flowchart by embedding the opposition-based learning. So this enhanced technique is used for extracting the PV parameters from using experimental obtained current voltage data and based here in the one-diode model. So the objective function will be obviously the one-diode model equation as seen, and we will have X, that is the vector of 5 parameters that are the photocurrent, saturation current, diode ideality factor, and the resistances shunt and series. For the fitness function, we will use the root mean square error, that is the RMSE error, that is widely used in this application. It is described by the following equation. So for the search range for the model parameter, we used the following search ranges since it showed an improvement and a better fitness. And for the algorithm parameters or hyperparameters were set to this value. For the cognitive factor, the value was set to 1.5. For the social factor, it was 2. And for the inertia weight, it is like adaptive, varying from 0.2 to 0.9. The maximum number of iterations used in this algorithm is 1000, and the number of particles is 30. The algorithm was tested in several PV panels. First of all, we used the monocrystalline panel, that is the STM64036, under temperature of 51 degrees. The tables gives the obtained result by several previously published algorithms in literature and by the original PSO and the enhanced proposed PSO. As you can see, the enhanced PSO has the lowest RMSE error. Thus, it has the highest accuracy. The figures show the constructed AV, or current voltage, and PV, that is the power voltage curves, using the obtained parameters by this enhanced algorithm. As you can see, the experimental data fit with the simulated curves using the extracted parameters. Also, this proposed algorithm reached this optimal solution with an execution time of 56 seconds, that is low. Thus, this proves that this algorithm has a fast convergence, as you can see in the figure below.
Please, we have exceeded the time. If possible, you can just go and finish the presentation soon. Thank you.
Almost finished. Okay. So we used another module that is multicrystalline from different technology. The tables show the obtained parameters. As it can be seen, the enhanced PSO has the lowest RMSE error compared to the other established techniques. And this graphs show the simulated curves compared to the experimental data. This experimental curves shows the high alignment with the experimental data, and for the time taken by this algorithm was 47 seconds. That is so low, and it has also good convergence. Looking at the figure below. Final test was done using another multicrystalline module under low irradiance, that is 300 watt per meter squares. As you can see in the table, the RMSE error is still low, and the experimental data fit well with the simulated curves using the obtained parameters. Thus, this algorithm has proved its effectiveness at low irradiance too. So to conclude, this enhanced PSO algorithm performs better than the basic PSO techniques. It helps us to solve the photovoltaic design problem by better estimating the parameters. And it has extracted the parameters very fast with a good accuracy. This proposed algorithm is valid for the characterization of different PV module types under different environmental conditions. Thank you for your attention.
Thank you very much for your good presentation.
You're welcome.
If there is, or if there are questions, would like you to come forward and ask questions, please. Are there anybody to ask a question? Fast, 1 minute is okay because I've already exceeded 10 minutes. Wow. I think there is no question for now. If you have questions, you can always text the presenter in private so we can move forward for the next presentation. Ege Denizi'nde deniz yüzey suyu sıcaklığının uydu verileriyle analizi with Aziz Ufacık and Nevin Betül Avşar, please.
Merhabalar, ben Aziz Ufacık. Tarım Bakanlığı'nda çalışıyorum harita mühendisi olarak. İzmir Katip Çelebi Üniversitesi'nde harita mühendisliği bölümünde yüksek lisans yapıyorum. Tez konum Ege Deniz'de deniz yüzey suyu sıcaklığının uydu verileriyle analizi. Deniz yüzey sıcaklığı deniz suyunun yüzeydeki sıcaklık değerini ifade eder. Deniz yüzey sıcaklığı, iklim ve ekosistem değişimi, hava durumu gibi süreçleri anlamak için çok önemli bir parametredir. Deniz yüzey suyu sıcaklıklarının artışı, iklim değişikliğiyle birlikte deniz atmosfer etkileşimini dönüştürerek hava olaylarını derinden etkiler. Artan SST, ani yağışları, sıcak dalgalarını ve fırtınaların şiddetini körükler. Aynı zamanda ısı ve nem transferiyle iklim dengesizliklerini tetikler. Nihayetinde deniz seviyesinin yükselmesiyle kıyı alanlarını ve ekosistemin riske atar. Deniz suyu sıcaklığı uydu sensörleri ile gemilerde ve kıyıda yerinde yapılan ölçümlerle elde edilmektedir. Uydular bu kapsamda yüksek çözünürlüklü veri sağlar. Çalışma alanımız Ege Denizi. Ege Denizi Türkiye ile Yunanistan arasında Akdeniz'in kuzeydoğusunda yer alır. 35-41 kuzey enlemlerinde ve 22-28 doğu boylamlarında bulunmaktadır. Coğrafi koordinatları. Çalışmanın amacı Ege Denizi'nde deniz yüzeyi suyu sıcaklıklarının 2000 ile 2024 yılları arasındaki 25 yıllık değişimi uydu verileri yardımıyla analiz etmek ve bu verilerin iklim değişiklikleri açısından önemini tartışmaktır. Bu çalışmada Kopernikus Cimens'ten 25 yıllık veri dönemine ait 0.05 derecelik girit aralığında uydu verileri temin edilmiştir. Bu uydu verileri tüm Akdeniz'i ve Ege Denizi'ni kapsamaktadır. Burada Ege Denizi'ne ait olan kısımlar çıkartılmıştır. Ege Denizi'ne ait olan kısımda toplam bu göründüğü gibi, görüntüde göründüğü gibi nokta olan kısımlar 9682'den girin notası düşmektedir Ege Denizi'nin içine. Deniz yüzey suyu sıcaklığı verileri Akdeniz için 2000 yılı Ocak ayı ile 2024 yılı Aralık ayı arasında günlük veri olarak net CDF formatı temin edilmiş ve bu veriler NASA panoyu programında açılarak tek formata dönüştürülmüştür. Toplam 9125 günü tek tek bu şekilde yapılmıştır. Ege Denizi alanı için belirlenen sınırlarda derece birine dönüştürülen SST değerlerinin Excel programında aylık ortalamalar hesaplanmıştır. Önce günlüklerden aylık, aylıklardan da yıllık ortalamalar hesaplanmıştır. Bu kapsamda 25 yıl 2000 ile 2024 yılları arasında 300 aylık SST ortalama değerleri elde edilmiştir. Elde edilen Ocak 2000 ile Aralık 2024 tarihleri arasında aylık SST zaman serisi ile elde edilmiş bu zaman serisi üzerinde analizler yapılmıştır. Analizimize göre mevsimsel değişimler çıkartıldığında 2000 ile 2024 yılları arasında 0.04 derece bir artış gözlemektedir. Kırmızı çizgi bizim lineer trendi göstermektedir. Yani yükseldiğini, 0.04 derece yükseldiğini görmekteyiz bu grafikte. Bu da tüm 300 aya ait tablo. Tüm ayların yıllara göre derece sıcaklıkları yazıyor SST değerleri. Bu veriye göre 2025 yıllık veri döneminde Ege Denizi deniz yüzey sıcaklığının en sıcak olduğu yıl 20.91 derece ile 2024 yılı olmaktadır. 2024 yılı olmaktadır. En sıcak olduğu ay ise 26.77 derece ile 2010 yılı Ağustos ayı olmaktadır. En sıcak ayımız Ağustos ayı. 2000 ile 2025-24 yılları arası Ege Denizi deniz yüzeyi sıcaklığının ortalaması 19.82 derece olmuştur. En soğuk ayımız ise 14.07 ile 2000 Mart ayı 2006 Mart ayı olmuştur. En soğuk ayımız deniz yüzeyi sıcaklığında Ege Denizi'nde. 2000 ile 2003 yılları arası SSD yıllık ortalamaları dikkate aldığımızda az önce bahsettiğimiz gibi en sıcak yılın 2024 yılı 20.91 derece ile 2024 yılı olduğu grafiğimizde de görülmektedir. En sıcak yılıyla en 25 yıllık SSD ortalamayı karşılaştırıldığında 25 yıllık 2024 yılı sıcaklık ortalamamız 25 yıllık SSD ortalamasından 12 ayın tamamında yüksek çıkmaktadır. Yani bu da sıcaklık derecesinin deniz yüzeyi sıcaklığının gitgide yıllara göre arttığını göstermektedir. 2000 ile 2025 yıl arası aylık ortalamaya dikkate aldığımızda grafiğimizde görüldüğü gibi kırmızı renkle gösterilmiş şekilde en sıcak ayın 25.51 ile Ağustos ayı olduğu görülmektedir. Ağustos ayları için neyse en sıcak Ağustos ayının bulunduğu yıl ise yine kırmızı renkle görüldüğü gibi 26.77 ile 2010 yılı olmuştur. 25 yılın ortalamasından çıkartılan haritamıza göre, sıcaklık haritasına göre kuzeyden güneye doğru sıcaklığın arttığı gözlenmektedir. 2024 yılında ise aynı şekilde sıcaklığın arttığı gözlenmekte olup genel olarak baktığımızda kuzeyden güneye doğru sıcaklık artmaktadır. Ve bu aradaki fark da yaklaşık 1-2 derecedir. Kırmızı renkle görünen kısımlar en sıcak olan bölgelerimiz. Ege Denizi'nin güney kısmına düşmektedir. Bu çalışma Ege Denizi'nde deniz yüzeyi sıcaklarının 2000 ile 2024 yılları arasındaki zamansal değişimlerini uydu verileri kullanarak analiz etmeye amaçlamıştır. Elde edilen sonuçlar Ege Denizi'nde deniz yüzeyi sıcaklığının yıllık ortalama değerlerinin 14.07 ile 26.77 derece arasında değiştiğini ortaya koymuştur. Bahsetmiştik 2006 yılı en soğuk yıl 14.07'dir. 2010 yılı ise en sıcak yılımız 26.77 derece ile Ağustos ayıdır 2010 yılı. Mevsimsel analizler yaz aylarında Temmuz-Ağustos aylarında deniz yüzeyi sıcaklığının 22 ile 27 derece aralığında en yüksek değerlere ulaştığını, kış aylarında ise Ocak-Şubat 14 ile 18 derece aralığında en düşük seviyeleri gerilediğini göstermiştir. Kuzey Ege'nin Güney Ege'ye kıyasla 1-2 derece aralığında daha düşük sıcaklık değerleri sergilediği gözlemlenmiştir. Bir önceki slaytta haritada gösterdiğimiz gibi. Ege Denizi'nde zamansal trend analizine göre SSC'de yıllık ortalama 0.04 derecelik bir artış olduğu gözlemlenmiştir. Ege Denizi'ndeki SSC değişimlerinin, deniz yüzeyi sıcaklığında değişimlerinin deniz ekosistemleri, balıkçılık faaliyetleri ve kıyı turizmi üzerindeki potansiyel etken değerlendirmede önemli bir temel sunmaktadır. Özellikle deniz yüzeyi sıcaklarındaki artışın biyoçeşitlilik, tür dağılımı ve ekosistem hizmetleri üzerindeki olası etkileri gelecekteki çalışmalar için kritik bir araştırma alanı olacaktır. Deniz yüzeyi sıcaklığının Ege Denizi'nde olağan dışı yükselmesi, atmosferik su buharı miktarında artışı yol açarak yağış ve rüzgar hızının artmasına, şiddetli fırtınaların sıcaklığına artış meydana gelmesine neden olabilir. Uydu sistemleri ve yersel ölçümlerle toplanan veriler, erken uyarı sistemlerini güçlendirmek ve iklim değişikliğine uyum stratejisi geliştirmek için hayati önem taşımaktadır. Bölgesel yönetimler kıyı koruma ve afet önleme planlarını güçlendirmek için bu verileri kullanabilir. Gelecekteki araştırmalarda uydu verilerinin yersel ölçümlerle entegrasyonu, deniz yüzeyi sıcaklığı değişimlerinin ekolojik ve sosyoekonomik etkilerinin daha ayrıntılı bir şekilde incelemesini sağlayabilir. Dinleyen herkese teşekkür ederim.
Biz teşekkür ederiz sunumunuz için. Şimdi sunumla ilgili sorusu olan var mı aramızda sayın hocalar ve akademisyen arkadaşlar? Do you have any question about the presentation? Of course, the presentation was in Turkish, but you may always ask a question if you have some question to ask or non-clear point from the presentation. You can always write down or maybe ask your question directly.
Bütün katılımcılarımıza teşekkür ediyoruz. Bu oturumdaki
Şimdi ben bir soru sorayım bu. Yani 2000-2024 yılları arasındaki bir tabii bu aralarda yapılan bir çalışma. Suyun sıcaklarındaki
kameralarımızı açarsak
bir hani gözlem yaptık. Hani bu zamansal ve mevsimler değişimler aslında
dijital olarak gönderilecek.
yani değişimlerin bölgesel
Teşekkür ederim.
farklılıkları
Sağ olun.
Doktor
Züde hemen
ile ilişkisi var mı?
Can you start your camera please?
Biraz sesli bir ortamdayım. Belki soru anlaşılmadı, gelmedi. Sesim gelebildi mi?
Efendim?
Sesim geldi mi? Soru
Şu an
ulaştı mı?
söylersiniz hocam. Tekrardan söyler misiniz?
Şimdi 2000 ile 2024 yılları arasında bu
Evet.
yapılan bu çalışmada deniz suların yani suyun sıcaklarındaki bir hani gözlenen zamansal ve mevsimsel değişimlerden bahsediyoruz burada. Hani bu değişimler asıl neler ve değişimlerin bölgesel farklılıklarla ilgili bir ilişki nasıl yapabiliriz?
Teşekkür ederiz hocam. Sağ olun. Sağ olun hocam. İnşallah. İnşallah hocam. Sağ olun.
İnşallah hocam.
İyi günler
Her
diliyoruz
şey
herkese.
için
Sağ olun.
teşekkür ediyoruz hocam.
Biz teşekkür ederiz. Sağ olun hocam. Tamam.
Evet, muhtemelen bir ses sorunumuz var. Neyse, şimdi belki sonra özleyeceğiz.
Hello, participants. I think the last presenter, I just came back from the prayers. I can see that the last presenter have presented, isn't it?
Aziz, sunumu kapatabilir misin?
I said I can see last presenter have presented, sir. This is the end of the presentations?
Yeah, it's the end of the presentation.
Okay, that is good. Just like from your instruction that at the end of the presentations,
Arkadaşlar kameralarınızı
all of
açabilir
the
misiniz? Can
participants
everyone
should
start
on
their camera,
the
please?
yes, should on their cameras so that we can take pictures. So all the presenters, if they are in us, please, they can
Selena,
on
can you
their
start your
cameras.
camera, please? İbrahim, Berkay, kameranı açar mısın? Abdifatah,
Yes,
please
all of
start
the
your camera.
presenters. Yes.
Sharon, Hatice, please start your camera.
Shamsuddeen Mohammed, I think the light is poor at your side. Maybe you just turn to the place where there is, light so that we can see your face very well.
Arkadaşlar herkese katılımları için teşekkür ediyoruz.
Yes.
Desteğiniz ve katkılarınızla güzel bir kongre oluyor. Hepinize teşekkür ediyoruz. I want to thank everybody for their contributions and participation. It's
Yeah.
going very nice, in my opinion. I hope it will continue. The Congress
So is
will
it taken?
continue,
The
next
picture, is
week,
it-
and I want
is
to
it
invite
taken?
you from now on. Thank you for your participations and contributions again.
Okay,
Will
thank you
take
very
the
much,
photo,
Prof.
please.